it says a 25-gram sugar sample is known to release 418 kilojoules of energy when it is burned. What is the heat capacity, kilojoules per K, of a calorimeter that changes from 20 degrees C to 49.3 degrees C when 25-gram sugar sample is burned? So essentially what we're doing is we're burning 25 grams of sugar. We know the amount of heat that releases, and what we want to find is the heat capacity of the calorimeter. So in previous questions, we've used the specific heat capacity, and the specific heat capacity has a mass term. The calorimeter is made of a bunch of different materials, so specific heat capacity doesn't usually work because specific heat capacity has a mass term and it's for a specific thing. Like, for example, if you have 50 grams of water, you can figure out how much energy is released. But your calorimeter has water and styrofoam and probably glass for a thermometer or metal and something for a stir and all this other stuff. So it doesn't really work as well. So instead what we use is Q equals C, the heat capacity instead of the specific heat capacity, times delta T, where delta T is still the final temperature minus the initial temperature. Well, in this case, we want to solve for C, so we have to divide both sides by delta T. So C, the heat capacity of the specific calorimeter, is Q, the heat, divided by delta T. Well, in this case, the heat is the 418 kilojoules of energy that's released when it's burned. So the sugar releases this energy when it's burned, and then the calorimeter absorbs that. The heat capacity is always positive. So what we put in here is 418 kilojoules. For the change in temperature, it's still the same thing, TF minus TI. So 49.3 minus 20, which is 29.3 K. And what we end up with is 14.3 kilojoules per K. Now, people may wonder, how did we go from degrees C to K without changing the temperature? So if we subtract these two numbers, we get 29.3 degrees Celsius. However, if we convert both of these numbers to Kelvin, this one is going to be 293 K. This one is going to be 322.3 K. So all I did was add 273 to this and 273 to this. If I then subtract these, it's 29.3 K. Because these are both changing to K when you subtract, the change in temperature in Celsius and the change in temperature in Kelvin are exactly the same. Said another way, 1 degrees Kelvin and 1 degree Celsius are the same magnitude. This wouldn't work if you were using Fahrenheit because that's not true of Fahrenheit and Celsius, but it is true of Kelvin and Celsius. So 1 degree is 1 degree. So the change in temperature, C or K, doesn't matter. We could just read the change in temperature in Celsius in Kelvin.